Good morning, all. Hope I'm audible to you.
Good morning, sir. Yes, sir. You are audible.
Yes, yes. And the screen is also visible to you, no? Okay.
Yes, sir.
Okay. So as we started last day, that our topic is basically electrophotography, and like we got introduced to the basic step of electrophotography. Now today we are going to see a bit detailed each of the steps. So as you know, the first step is called sensitizing. Okay. Now, if you think about the photoconductive drum or plate, it is having a structure like this. Okay, now as you know that it is having basically two things. Although there is a detailed structure that I will come afterwards, but as of now we know that this is called the photoconductive plate or drum. It can have a drum kind of construction also. Okay, it can have a construction like this also, where we have a drum, and then that is coated with the photoconductor. So this type of architecture also can be found, but anyway the fundamental process is it is a photoconductive plate or drum. Now this is having how are we going to sensitize it? Sensitization is fundamentally the step is depositing charges on photoconductive drum. This is what is called sensitizing, or this is also called charging, as it is going to deposit charges on the photoconductive drum. Although there are different research processes and research development works onto that, but till the date it is the most commonly used technique is called corona discharge. Okay. So corona discharge process is one of the most commonly used technique in sensitizing the photoconductive plate. So how it works now? What is corona? Not this corona like with what we are actually getting lot of troubles with. Okay. Here the corona discharge principle is something like, suppose you have a very thin wire. Okay, thin conductive wire, and like it is not connected to anything, it is an open ended, and you connect it to a very high voltage power supply. High voltage in the sense in terms of 6 kV to 12 kV. Okay. So one sec, just I have not started the recording, I think. Okay. So it can go from something in the range of 6 kV to 12 kV range. So you can understand that it is a very high power supply, and it can be DC or AC, but normally we consider a DC voltage. There is some kind of arrangements where we use AC voltage, but that is not very commonly used. So majorly it is a DC voltage. Okay, and the range is, as I already told, it is in the range of 6 to 12 kV. Okay, so when this means highly conductive wire, which is one end is open and it is connected to such high voltage, what happens? The charges start flowing from this particular wire. Okay, and this wire is basically called the corona wire. Now what happens? Coming over here, they don't get any place to go. This high flow of charges, they don't get any place to go. So what happens? They start accumulating in this point, and they start ionizing the air around it. Okay. And due to this reason, what happens? We get a, we get a blue kind of glow over here. a very bright and pointed glow over here. This is what is actually called corona. Okay, if you can remember the eclipses of sun and all, like everything was getting covered, only a small, like a ring kind of arrangement was happening, so that we used to call corona. So the same thing over here. So this is called the corona thing. Now what will happen? These charges, these free charges which are actually in this vicinity, they are actually, over here. These are the free charges which has got in due to this corona discharge principle, and you can also think that this is a kind of induction charging. Okay, so what is going to happen now, so this is a very high potential area. Okay, because it has got charges over here, and these are the free charges, these are the mobile charges. Okay, now below that this photoconductive plate is there. Now this photoconductive plate, if you just ground it, then what is going to happen? These charges starts moving into here. Okay, and since this is a photoconductive drum, so you have to remember this thing, this is a photoconductive drum, so it will only allow movement of charges only it is getting subjected to light, otherwise it works like an insulator. That means in dark it works like an insulator. Or you can also think that this entire arrangement is like a battery, that means it is a kind of capacitor, that means it is going to hold the charges in dark. Okay, so what is going to happen, these charges will come over here and they get deposited on this photoconductive drum or plate. Okay, so this is the fundamental way how it gets charged. So if you are asked about the charging, you need to talk about this corona discharge principle which is used for charging. And corona also, they have different kind of arrangements. So let me draw the most commonly used three arrangements in corona charging. Okay, and if not stated otherwise, this this plate or drum, what I am going to draw below this is the photoconductive drum. I am not going to draw the multiple layers always, but it is understood that it is having this, above the plate you have this photoconductive layer. Okay, and there are three different arrangements. So I'm first, let me draw it, and if you want you can draw also. Hmm. So this is the first arrangement. Draw it by smaller so that accommodate all of them. This is the first arrangement. So these three type of arrangements are normally used in case of corona charging. The first one that I have drawn, okay, this one is called a three-wire Chorotron. This one, this, let me name it A, B, C. So A is called three-wire Chorotron. Okay, and as you can see that it is basically having a plate above it which is actually connected to the power supply, and due to this power supply connection, what happens, these corona wires also get a very huge induced power over here, okay, which in turn actually ionize the vicinity and the charge movement happens. Okay, so this is called a three-way Chorotron. In the next case, you can see that it is almost similar to that, but it is having a a control grid actually, uh, which is actually parallel to this way. Okay, so this arrangement is called a Chorotron. Now, what is the advantage of this? Now, as you can see, now the thing is, okay, let me tell what is this, then we can understand, because the purpose of introducing this is same. So, this one is called a shielded Chorotron. Okay. Now, this shielded Chorotron and Chorotron, they have an added advantage, because here what you can see that you don't have actually a good amount of control on the flow of the charges, because it is utmost important that your plate or your uh, drum, whatever it is, that need to have an uniform distribution of charges. Okay, so if you have different kind of density of charges, that means you are having an like a unpredictable potential distribution. So if this is very much non-uniform, then what is going to happen? You cannot have a good control on the amount of charges you want to retain and the amount of charges you want to means flown away from this particular location when you are exposing. Say for example, you have, just I am giving an example, if you have a charge deposition like this, which is I am considering as uniform, and suppose you expose it for 4 minutes, just I am giving some rough values, these are not correct. So 4 minutes, and here also you are giving the same amount of light. So in both the cases, just for example, let us consider that 4 charges will be taken away due to this exposure. But suppose instead of this type of charge, you have a non-uniformity like this. So here you are getting in 4 minutes, you are 4 are there. So this is fully getting discharged after the exposure. But here it is not going to happen. Here these charges will remain. So you cannot actually get a good control on what you want to get at the output, because each of the step is going to give you the output as per requirement, and there are two very important things. One is called under development and over development, and these terms will be repeated many of the times. That's why I have introduced so uh, much in the beginning of this. What is the meaning of underdevelopment? Underdevelopment, you are not getting that extent of intensity you are looking for. That means suppose you want to get an area like this, but you are getting an area instead of this, you are getting an area like this. Okay, that means you want an intensity like this, but you are getting an intensity like this. Now there can be several reasons. Considering charging, what is the reason? It has not deposited or it has not discharged the amount of charges that is needed. Suppose to have, you can just take it in the back way. If you want to attain this, just think that you need 10 charges, but instead of 10 charges you are getting 6 charges over there. That's why it is underdeveloped. That means you are not getting the intensity that you want. And just the reverse case of this is called overdevelopment. That means you want this, but you are actually getting this. And overdevelopment, a very common example, whenever you Xerox something, you might have seen that there are many unwanted black spots around your uh, Xerox copy. Okay, now this is one of the reason that this has come. This is the overdevelopment. That means in some of the non-image areas where you don't want the toners to be there, or this should be printed, you are having charges over there. Because of this reason, because you have said that it will, if you expose for 4 minutes, all the charges will go away. But it has not gone because you don't have a proper uniformity in charging. So to introduce this kind of uniformity, these two arrangements have been came into picture. One is Chorotron, one is shielded Chorotron. So why they are useful? The first point, as I already told, that what are their advantages? The first point, as I already told, is uniformity in charge distribution. But there is another one also, that is, if you are considering a work of a line art, line art means, say you have a single intensity like this. But suppose if you want the line to be something like this, that means you have a varying intensity. So in that case, this cannot work properly. But here it can work. How it can work? You see, say for example, this is going to, you know, give the charges out. Now, one basic principle, you know, that charge flows from high potential to low potential, right? Now, how long it will flow? It will flow until this become low and this becomes high, and they come to a stable point. That means there is no charging, there is no potential difference, and there will be no more flow of charges. Correct. Now here in this case you don't have any control. Whatever the voltage you put over here, accordingly the charge get out. But here you can see you have a control between this and this. Now if you see that, suppose this is having 8 kV over here, and accordingly this is getting induced to 6 kV. So what is the charge difference? It is becoming 2 kV. So this will, bring out some amount of charges. But suppose instead of 6 kV you make it 3 kV, that means you are having a higher potential difference over here. So more charges will come over here. So if you want to relate the fact to this kind of work, then suppose you want this to be printed, and for the time being you just keep in your mind that darker output need more charges. This is a very simple, but for the time being you can think of this just to understand. It is not actually this simple, but anyway, just for understanding the facts, we can have this kind of easy correlation. So here, suppose I want to make this line, I can deposit more charges, so I can keep a small value for this particular shield. This particular grid. This is a grid. We don't call it a shield, we call it a grid. And again, when I'm going to make a line like this, I need very small amount of charges over there. So for that reason, I can have a higher voltage to this shield, and I can have a lower potential difference. So low the potential difference, you can see less charges, lighter print. Okay, at the same point of time, like high potential difference, high charges, and darker print. Sometimes when you go to a Xerox shop, you may say, or even in a printout, you may say, দাদা আরেকটুখানি ডিপ করে দিন, আরেকটুখানি কালো করে দিন, বা এটা খুব কালো আসছে, একটু লাইট করে দিন. So you will see that they will adjust. Now these adjustments are, there are many ways it can be done. So one way, when they put a control knob or something, what they basically do, they vary the potential difference of these two. Am I able to make you understand like how it is done, how the charging can be modulated using this kind of things?
Yes, sir.
Okay. So these three are the major ways for charging. So let us quickly see that what is the construction of a plate. That means a photoconductor or photoconductive plate. How, what is the construction of this? Okay. So let me draw it first. So this is the structure of a organic photoconductor. Okay, this is an organic photoconductor, and most commonly used, this most commonly used this photoconductive material for electrophotography is amorphous selenium. Okay, this is the structure. So you please draw it. Okay, and then I'm going to tell you the next thing. Okay, have you drawn it? Okay, so as you can see that what is given here, the first layer is a charge transport layer. Now this layer is not where if the light falls, the charge start move, but this layer helps through which the charges actually move. Okay, and this is the charge generation layer, and in this side what is written, that what is the component in this layer. So here we have charge transporting molecules dispersed in polymer binder, and here we have photoactive pigments. Okay, that is why this is the charge generation layer. This is where the charge generates. Okay, after the light falls upon, this is the layer where the charge actually generates. Okay, and polymer layer, this is also called an undercut layer. This actually helps the transportation of charges from here to here when it is not been exposed. Okay, and finally it is a flexible metallized film or rigid aluminum layer, which is basically the base layer. Okay, so this is how the organic photoconductor is constructed. Okay, so once this is done, the next step, as we know, that we are going to talk about is called exposure. Now exposure, this is having, basically it is basically used using the light. Okay, however, if you have a digital Xerox machine or even in a laser printer, we use the laser to do that. Okay, we don't use any light source actually, but we use the laser to do this exposure thing. Okay, now how it happens, so here also we have a small diagram. So let me just draw first. Okay. Now here, as you can see, that we have different combination of lens and mirror. Okay. So this lens mirror assembly is very important because like we have many of the tasks to do over here, as to focus the light properly in the location where we want to expose. Now to accommodate that, what is there, we are having a laser diode. In other case you can have a light also, you may not need a laser diode, you need a, if you have a light source, that also you can use. But in that case we use a particular lens which is a cylindrical lens. And this kind of cylindrical lens, what it helps, like light in general, they are having a nature to spread. But if your light is not well concentrated, then you cannot actually point it to a particular location. Now, this kind of lenses, these are sometimes called cylindrical lenses. Now, these cylindrical lenses that help to concentrate this light rays, okay, because light rays in general they will always try to get diffused, or okay. So this is a thing, this cylindrical lens that help to concentrate the ray. So but mostly as you see these digital machines nowadays, where we don't use this kind of analog light source anymore, like halogen lamp or any other kind of lamps, but here we use a laser emitting diode, that is the LD. Now this is emitting, now it is going to a mirror. Now this mirror is having different function. One major thing is, as you know, that it is going to make the lateral reversal of the object. Otherwise, like you won't get the D like this. Instead of that, you will get D like this. So this kind of reversal and all is actually accomplished using this kind of mirrors. So it gets over here, it gets reflected. Now this is one of the most important thing. This is called a polygon mirror, and it actually rotates. Okay, and this rotation of the mirror is actually, it is synchronized with the movement of the this drum, because if you think of a drum, it is actually rotating like this, and this is also rotating. So at once this facet is done, it actually rotates, this facets come, and here also this also rotate by one scan line. Now what is scan line? Scan line is, as the name says, that suppose you have a document like this, like this is one scan line, which is very easily understood in case of a inkjet printer. You will see it prints one line, little bit paper comes out. Again a line printed, little bit comes out. So because they print scan line wise. Okay. So here this rotation of the polygon is actually synchronized with the rotation of this photoconductive or photoreceptive drum. So this moves by one scan line and this moves by one facet. Each of these faces, suppose if you think of a polygon, so this each of this thing is called a facet. This is called a facet, and it is having a fixed width. Now this W is actually synchronized with the with this thing, with the rotation of the PR drum. So one facet movement over here equal to one scan line movement of this drum. Then it again goes to another cylindrical lens, which actually helps to cover the width of the PR drum, because as in the previous pictures also we have seen that although we have the best material like this, it is not entirely covered with the photoreceptive layer. So this width, because, and this is the reason that with a single printer, in none of the cases, not in conventional, in digital, you cannot print just any size. All the printers have a constraints in terms of their size. Say for example, some expensive you can print A3. That means that is the maximum coverage of the print area by your photoreceptive drum. Now this light which is coming from here, this need to cover this entire width. So that is why this lens is used. Okay. And finally it goes on the PR drum, this photoreceptive drums. And what happens basically now when this light falls upon, you have the photoions over there. These photoions actually get, so when they come over here, they are having this photoions like this. Now what is going to happen, say for example, okay, I am showing you, and there are a lot of other physics over here. I'm not going into that detail because the scope of the subject is not that much. So just if you think that what is going to happen in a very surface level, so in the previous one, in the previously just we said that we have two layers. This is a charge transition layer and this is a charge generation layer. Now what is going to happen basically, you know, after charging, you have the charges like this. Okay. And after the light falls, what you have now, you have this things over here, photons. Okay. Now what is going to happen? This is the kind of stuff over here. They are together, but the moment they come over here, what is going to happen? This negative charges, what they are going to do, they are going to move upwards, because this potential is much higher than this. So this, they are going to here and they are going to neutralize these charges. So after exposure, you won't have these charges over here. And that is what actually happens in terms of physics, what actually happens due to this photoconductivity, or this photo means the exposure. These things actually, they go up and they neutralize these positive charges which have been already deposited over here. Okay, so this is what is the actual stuff going to happen. So charge generation happens over here, and this transition, charge transition layer, they help them to move upward, because like they have a mobility, and this mobility is not very high that they can move this much distance. So this charge transition molecules which have been bound over here, they actually help them to move up and reach up to this place. Okay. So this is what happens in case of exposure. So that's all for the day. So I'm just going to make a small sum up of this, and then if you have any doubt, you can ask me. So today we have got introduced into two major steps. One is the charging and another one is exposure. Under charging, we came to know the corona charging and the different arrangement of that, and the construction of photoconductive drum or layer or plate. And in exposure, we came to know the lens mirror arrangement, and also a bit of the the principle of discharge, or yeah. So these two things we have come to know, and that's all for the day. If you have any doubt, you can ask me.